docs where they say local labels are just numbers, but didn't like that.
Yeah, I mean, the purpose of the local label being used there is for us to define blocks that we can jump to without conflicting with other labels in the generated assembly. So
yeah, the docs say you have to do it in case the assembly is duplicated.
Exactly.
You know, so I'm quite sure we want to use a local label. They don't tell me how to do it. Although I guess I probably should just look for the.
I mean, you can write it, unless I have forgotten. I'm pretty sure you can write straight up assembly, right? So you're basically limited to whatever the assembler is for the platform you're targeting. The thing to keep in mind is the syntax for local symbols, amongst other things, changes depending on which target you're on. Linux and Mac OS have different syntax for symbols.
Okay. Well, that will be
so I believe on Linux it's dot prefixed. On Mac it's __ prefix.
Okay, maybe I'll try the __, but then I have to figure out how to make it be okay to be portable. Because right now we just have as an x86 target, and I really wouldn't want to have to redo the whole thing.
Yeah, my branch has all that to deal with the difference between. In fact, I'm positive that I admitted those changes. There should be 2 sets of assembly for the dynamic call stuff, that like one that compiles for Mac, one that compiles for Linux. I guess it is it's possible that that didn't get into the assembly that lives in the scheduler.
Well, I haven't looked at your branch because I didn't want to pull in.
No, I'm talking about what's pushed in develop right
now. There's still
the dynamic call assembly. There's 2 files, and then one for, I guess, the scheduler assembly that uses LLVM's ASM stuff. So that one might be different. It might not have 2. Yeah, I don't think that one. I don't think there's 2 sets of assembly functions for the scheduler stuff. The swap sec. So it's only the dynamic call stuff that has to have 2 different files, and in that case, it's because I wrote just a regular assembly file and including it as a global ASM.
I mean, I think that's fine because I want to say that we actually put no inline on the swapper, so it shouldn't be it shouldn't duplicate the code.
Yeah, I mean, I wasn't worried about duplication. What I was talking about is that for anything that requires like target specific syntax for the assembly, aside from like CPU architecture differences, which obviously are completely different sets of assembly, you have to write the assembly for at least the LLVM sem function or macro to contain the different syntaxes for labels and stuff. So I don't think LLVM ASM required that. I think it kind of magically did that for you. I think I can't remember 100%, but I do know that the just plain assembly files I wrote to package up all the dynamic call stuff, that does have platform specific assembler in it, and both for Mac OS and Linux on x86-64. But that does not use LLVM ASM, that uses global ASM. which is different. That's basically like you're writing plain assembler. There's no like interaction with LV or with Rust at all, aside from making it simple to link it in. And we might have to transition to doing that, I guess, with SwapStack. I'll need to double check and look at that again to see what's going to be the best approach there. Because we're also going to have assembler for ARM, and ultimately for all this stuff, there's going to need to probably be a WASM shim too, but that depends on how the WASM stuff shakes out. So. But certainly for any of the other native targets that are not WebAssembly, we're going to have multiple sets of assembly.
Yeah, and then besides the label, the other big thing was the ASM. They decided to switch the whether it was AT&T and Intel. So LVM ASM is AT&T, and it went to Intel when they switched to ASM for some reason. Like they just decided.
Oh, right. Why did they? Okay, as long as they didn't switch the default for LVM ASM.
No, I don't know why they decided to do the switch, but of course it meant like switching all our calls. It builds fine. It's just when it links in that for some reason, then it realizes that the label's bad. So however they compile it the first time, it doesn't realize the local label's bad until then. But at least it seems to understand everything I did. But since it doesn't check the link till then, there's still an off chance that maybe it doesn't understand the CFI directives. I'm somewhat worried about that now, but they seem to compile fine, so hopefully. But we'll see.
I mean, based on my initial reading of the new macro, it should have supported all that stuff. But like I said, I didn't dig in super deep on it. It was mostly just skimming it to see what was changing. And if need be, we can switch to just writing plain assembly like I did for the dynamic apply. The caveat there, I think, is that we were just using LVM ASM to make it easy to define that function. But if they're going to complicate things for us, then I don't really see any reason to use it at all. It's not like we needed to have the function defined in Rust. It was just convenient.
Yeah, with the new restrictions on naked, I'm not really sure there is an advantage. I guess the only advantage is that like the Rust symbol is known, so that the new ASM macro, you can do sim on like another function's name. So like when you have to call the naked function from a non-naked function with the ASM macro, you can sim on that name and Rust will check that the name exists. But since it's naked, it doesn't know the calling convention. So you're not like getting any guarantees about you're using the right registers. So like that's gone. So like
I have to assume that they're gonna like probably remove the ability to do that anyways, because if they're saying that their calling convention isn't stable, so naked can't work the way that it has, then the same is going to apply when a Rust function is a callee. I don't know why they would let you reference like a Rust symbol directly if they're saying that the calling convention is basically a toss-up.
Yeah, I'm not sure either.
I do know that there were some annoyances around how like various features of Rust interact with naked functions and inline assembly. There was duplication in generated assembly, like in some cases just unnecessary, like moving stuff onto the stack and off the stack. I think that's just because like the default sort of code generation for Rust functions does some stuff, and then naked strips out some extra things, but it doesn't strip out everything in the function, which is more what you'd expect. No function prologue at all. It doesn't do anything, and leaves it entirely up to the definition of the naked function. But that's not what they were doing. So I mean, it makes sense that they are maybe changing the behavior there a little bit, but it's surprising that they're breaking that for backwards compatibility reasons. But I guess since it's unstable, they're just kind of like
Yep.
tough shit.
Yep. They're in their rights to do it. Those are the rules of unstable.
It's just that naked functions are used in like a lot of embedded and like operating system projects I know of. So I imagine there's probably some issues there, but I'm not sure how all those projects are using them to begin with. I think our use with involving parameters is anyways fairly like a small portion of people using naked functions are doing that.
It seems like one of the descriptions of it on the forum was the reason they stopped naked from allowing parameters was specifically for the case of like it was someone talking about kernel code. So it may have been like Rust in the Linux kernel or one of the Rust OS projects where like literally they kept getting it wrong because since they were switching to kernel code, they don't get in a prologue. Like you're already in kernel space, so like you can't. It was something like that in the forum discussion. So maybe they did this change because they realized that it was introducing bugs into the kernel projects.
Yeah, that would make sense. I mean, it definitely was a little buggy, that interaction. So once I got it figured out, I left it alone. But since they're changing that behavior, now I'm questioning whether using inline assembly makes any sense at all. The only, like, we weren't using any features that would be like, that we would miss. We were defining a constant and then referencing specific parameters and specific registers. But if we mark a function as extern and call it like a C function, then our inline assembly will more or less behave the same way. The registers will follow the calling convention for the platform it's on. And we don't need to define the constant in Rust. It's just a stupid like dead beef constant or something. So I don't know. The more I'm thinking about it, the more it probably makes sense to just move any assembly like that out into standalone files like we did for dynamic apply and just handle it ourselves entirely, mark these functions as extern.
Well, if I can't get it to work, then sure, I'll switch to that.
Sure. I mean, if you want to, see how far you get with it, that's fine. I'm trying to think if there's any other reasons specifically why I wanted to do that in Rust. I don't think so, but the primary, focus in that swap stack function is to keep it as like minimal as possible, right? Like we want those context switches to be as cheap as we can make them, while still doing the interaction with the scheduler, of course.
Yeah, that's the thing. I don't know if the normal non-naked function immediately calling assembly that then calls the naked function is more overhead than the old code that they said was incorrect where you had parameters. Like I don't know if that's more prologue than the old version that had parameters and not a prologue. And so
I mean, we
know
can
if
check
swapping
that
got
easily
slower.
enough. Like whenever you finish doing your translation and you think it's working, like the very first thing I would do, and maybe even before you get it working, is to dump the assembly from the Rust compiler for that crate, and dump the assembly for the swap stack function and look at what it's doing. I mean, you're probably going to have to do that anyways to make sure that it hasn't broken anything, any assumptions we're making, because there's various rules you have to keep in mind for the state of the stack and the calling convention. So stack alignment is the big one.
Yeah, so that was a weird thing, was that some of those options we used are gone now. One of them is now the default, but one of them, like, I couldn't find the equivalent. So
Which
I'm not
one?
I want to say it's the alignment one, unfortunately.
Align stack?
Yeah.
That must be done by default, I would think.
Yeah. I think that's like one of them is default, and then the other weird thing is that they it's a rule that assembly naked must be no return. I think, but like I don't know if that makes sense because like don't we technically return from swap stack when we swap back to the stack?
Yes,
But I think
but I
no
think the way
return
the
with
function is defined is, well, it's not marked as no return. It's just a void function effectively. You know,
yeah. So that
it's
I don't.
supposed to return, it just doesn't return anything.
Yeah, I don't know what that means for like because it says it's a requirement. Like it literally won't compile unless you do the no return. Not on the outer function, but on the ASM macro, you have to say no return, and I don't know what that means for our function. We'll
I
see if
mean,
it behaves or not.
it, I think what they're trying to do is firm up the way that the compiler sees naked functions, uh, where if you could define them as returning a parameter or taking parameters, like now you have to rely on that naked function correctly following Rust calling convention, and the Rust calling convention is not stable. So I think they wanted to make it so that the compiler never assumes that the calling convention for a naked function is being adhered to. And by preventing you from being able to pass parameters um, and from returning values, they don't have to worry about that. The compiler just can not have to think about it. That does complicate, obviously, the ability to do much of anything useful with a naked function. But in our case, that's why I'm thinking we'll probably have to switch to using extern, at least for passing parameters. Um, as far as returning values go, we weren't returning anything anyways. The issue with a no return, it's strange to me that they require that attribute to be set on a function.
Well, so
I
the
might
weird
want to dump the
it's
LVM
remember
IR for that.
it's the ASM block that's no return. The actual function itself is just void. It's not like goes to bang. It's not like panic. It's just the ASM block
Sure.
that is no return, which was weird to me. Of like the function itself isn't no return, just the assembly block.
Yeah, that makes sense. That makes perfect sense. I think the reason why I set it up, like most recently, I had to do some like finagling to make it so that I can return from the assembly we wrote correctly. But I think ultimately where I landed on that is I stripped out the manual handling of returns and just let the function do the thing it was doing. Actually, I think it used to return a Boolean value, and I changed it so it no longer does that. It just returns void. I would have to look through the Git history there if there's even enough history to reconstruct that timeline. But I know that there were some problems with how the prologue is set up with naked functions. There's not supposed to be one, but there is. And then the returning of things. I know I found that the generated assembly dumped from the Rust compiler, if I set up the function or wrote the assembly to do the returning myself, there would still be generated code to do a return.
Mm-hmm.
And so naked functions with inline assembly weren't really naked. They still were wrapped in like a prologue and epilogue.
Yeah, I saw that on the forum too. That was an issue.
So I think that's probably why they've made some of these changes, is so that it's clear what's happening there. But as far as we're concerned, I don't think that matters. The only one that's going to be a problem for us is the receiving parameters. I'm not sure how you're going to do that. I mean, we can't really get around the fact that we need that.
Well, so like what I said, since the naked function you had to call, I did an ASM just call using the sim thing, and then I did in of RDI, RSI, and RDX. So I reused the same ones you were using in the LVM assembly. I just split using the registers in the non-naked version, and I'm hoping it works out, that they don't like reset them or clobber them. But I think it should because the call happens inside of ASM block. But I'm
Yeah,
not sure.
if we have to do that, we definitely should just say fuck it and move this out of
Right.
the
So that's
inline
the thing of
assembly
like,
stuff.
it seems so stupid that that's how naked function is supposed to be used. That the only way to call a naked function with arguments is another ASM block. I'm like, why is this useful?
Yeah, I mean, the problem there, of course, is that now you've got all the functions set up and tear down of that like shim to do the call. And that's just wasteful. There's absolutely no reason to do that. So
Yeah,
if that's
it
what
feels
we're being forced to do, then I don't think we can probably use that.
yeah, it feels like the old swap one was like literally here's the assembly to swap a stack, really efficient. And this one is like I'm going to do a function call and then I'm going to do the efficient thing. Obviously,
Right.
the second function call to the assembly is not as bad, but like it shouldn't
Well, the
actually be a
problem is all
call.
the overhead there is uh yeah, like ideally what you'd want to do is just sort of like a unconditional branch
Yeah,
to the target function because you've already set up, registers and stack the way they need to be. You don't need all the overhead of, the function prolog and epilogue that normally gets wrapped around those things. And then of course the naked function, the way that gets generated anyways, has some of that shit too. Although less of it now that they've enforced that you can't pass parameters. So it just ends up being a lot of excess, you know, manipulation of the stack and registers. It's probably better to just treat it like a extern C function because that gives us both the guarantee of the calling convention as well as letting us have a lot more flexibility in how we write that, the actual target function itself.
okay. Well, if I fix the, I noticed recently that some of the other builds weren't related to this. So if I fix those and get this, I guess I'll have to hit you up with how to do the external file way of doing this.
Sure. Yeah. I mean, the way you can look at it is if you look at the dynamic apply setup, you'll see how I've kind of set that up. And if you have any questions about that, I can definitely help walk you through it. But I think for the most part, it should be fairly clear. There's not a whole lot of stuff going on. It's mostly the standalone assembly files, one for Linux, one for Mac OS. In theory, eventually one for Windows. And then that gets replicated for each CPU architecture. So right now, in the develop branch, it's just for x86-64. But I've written assembly for AR64, both for Linux and Mac OS, and then any other target CPUs
Okay, yeah,
we
I
want to
found them.
support.
The .s files under dynamic call inside of
And
core.
then there's a Rust file that has just the global ASM definition in it. I don't think there's much else
Yeah, it's
in
just
that
literally
file.
include that string, so you're just inlining it from the file, which is nice. Okay, and so this would be back in. This is still an AT&T syntax then. Okay.
Yeah.
Okay. Yeah, I understand, and that'll be easier because literally just copying the code that we had in the LLVM ASM macro, which would be easier.
The
I don't
only
have to
thing
worry
you'll
that I
probably
translate it
have to be
wrong.
aware of is that, I mean, the swap stack function, any assumptions we were making about calling convention was that, it was following the sysv ABI on Linux and Mac OS. So that just defines which registers we're expecting the parameters in. So I don't think anything changes there, but you'd need to make sure that, the registers that we were relying on are the correct ones. And then
Well,
you'd probably
you're
have to
using
add a
RSI and
little bit of
RDI, so
code to
that's
deal with the
those are
return.
normal parameter arguments. So I think you're fine.
Right. I just can't remember if, when we were saying, okay, here's the two parameters and here's which registers they get mapped to, and the inline or the LVM assembly macro, that they were in the correct order. I can't remember if they should have been.
I'm pretty sure they
But-
were. I mean, you even have the comments about which registers you think they're going to be, and even though you were doing, like $0 and $1, you say the register names, and it matches the names in the colon list at the bottom.
Yeah. Okay. And then
The only thing weird is the dead beef constant being in the
return
register
subclass.
too. But at first I'm like, why is this? We
Yeah.
support constant. I'm like, right, because there's actually no 64-bit immediate opcode, so you have to put in register.
Yeah. Yeah, that's the only annoying part there. But I mean, that's easy enough to replicate in just plain assembly.
Mhm.
Yeah, I think that probably is enough. For that constant, the way to handle that is to just define, like, use .quad or something to define a constant. And then you can reference that, like move it into a register. You'll need some extra assembly to do that part, but for sure you can find like a Stack Overflow post to help with that.
Okay.
I don't think I have any code in the dynamic apply stuff that does that specific thing to help, give you sort of a reference point. But if you run into any blockers there, definitely let me know.
Okay.
Yeah, I mean, you normally can't do that with like the inline assembly macros, but with global ASM, you definitely can, because then you're just sort of like write whatever you want.
Mhm.
I mean, it's not implicitly inside a function, which is kind of the benefit there. So you define the function in assembly instead of letting Rust define it for you. And since it's not, the context is not inside a function, you have access to all the things you would normally have access to with raw assembler, which is kind of handy. Speaking of the inline assembly stuff, I've pretty much finished up the translation of the dynamic apply stuff to AR64. I still need to wire up a test setup to make sure it actually works. But
What
the
is the name of the
translation,
calling convention?
less
Is it still
functional.
considered System V for AH64, or is it different?
It's different. I mean, it's very similar. It's just the registers are different. I guess maybe it's the same ABI, but it's just, CPU architecture differences. But I think of them as completely separate because, none of the rules really make any sense across architectures. But on AR64, the same kind of setup is there. You have callee saved and caller saved registers, temporary and scratch registers, and the set of parameter registers that are used. And it pretty much lines up more or less with the way it happens on XE664. With the benefit that AR64 has a bunch more scratch registers, which is nice, makes it a lot easier to work with stuff. The only thing that is super annoying is that AR64 is a load store architecture, so you can't directly reference memory operands in instructions. You have to load stuff from memory into a register and then work only with registers.
Well, yeah, but that's what
so
makes it
there's
a
a lot
RISC
more-
architecture. Like, they didn't want to make the opcodes that complicated.
Yeah, I mean, it makes it, a lot easier to have sort of the relaxed memory model that they have because, you're much more explicit about when you're doing loads and stores. But the downside is that it makes the assembly a lot more noisy because you have a shitload of loads and stores that you wouldn't have necessarily in x86 Anyways, I'll try and get that pushed this week. And that'll probably line up with the stuff that you're doing. Since there's some overlap there, keep me posted on how you're approaching the x86 side of it, because I'll try and make sure that we mirror those things.
Well, the
But for
PR
now, I'll probably just
is ops, so I can get the builds to fail, so you can look if I did something that will affect it.
okay. Yeah, I'll try and I'll probably just define the scheduler assembly, the swap stack stuff, in a separate file, knowing that that's kind of the direction you're going to be going there. And then any tweaks that we need to make to merge those two sets of changes. That should be fairly simple. So,
Okay.
yeah, that's it for me this week. I was kind of busy with work the past several days, so that's going to calm down a little bit this week, though. So should have time to wrap that stuff up.
Yeah, mine is, as everyone can hear, it's just getting the builds to work. I'll work on it again on Friday.
I was reached out to by Francesco. Apparently they're getting a new code beam ready, and he asked about Lumen. I told him that we want to wait until we have something tangible to put in people's hands. I don't think it's
sure, yeah.
What's that?
I said sure, yeah.
Yeah, no, I just don't think it's worth kind of doing the hype train right now until that point. So I guess we'll catch him on the next code beam.
Yeah, since we don't have that many viewers to this, I would prefer us to be like done, and then do a presentation, and then try to do conference driven development again on this.
Right.
Especially with like all of us being either on job or on client work, like we don't have the time for that.
Yep.
Yep.
That's it for me.
So I have finished moving over the front end to the new term stuff, removed a bit of code there, and I only have double digit of error left in the interpreter. So most of what I'm doing is just like removing duplicated code and making sure things are a lot cleaner. Yeah, there's not that much left. Most of the error sets left are just simple refactoring stuff. And I think there was one other thing. Yeah, I set up a runner on the cluster, but I don't think the runner operator has an option for like only running commits that are signed. So we might have to like do something ourselves there if we want that.
Well, you can restrict that in the action, I think, by making sure that the workflow events only run when certain conditions are true.
Okay, well,
and one of those could be whether it's signed. But maybe we want to verify that in the runner itself. I mean, I would be interested in that as well for my own use of it. Like, obviously, the repos that I'm using that operator on, or the controller, I mean, are private, and so nobody has access to run stuff with that runner that isn't part of the organization anyways. But validating signed commits would definitely be an interesting extension of it, especially for more public projects. Because that was one thing that stuck out to me too with the self-hosted runners, is that it's very easy to have like arbitrary code run on those environments, and you have to be quite careful to avoid opening that loophole.
Yeah, and I mean, it's really the way it runs containers. I don't think it would be very difficult to get out of them. So,
no.
I mean, like the better approach would be to use something like KubeVirt or something and just spin up a virtual machine from a template for every like action run. But I don't know if I want to like work on that.
Yeah. I mean, the other option is to, it depends on your Kubernetes environment and stuff. But if you set it up, for example, like in GKE, if you set it up to run with all the fancy security features, you can lock down those environments pretty tight. I guess the part that's problematic is how the actions runner interacts with Docker. I think you have to run it privileged so that it can spawn a Docker daemon.
Are there cloud providers that rely on like containers for isolation in the context of Kubernetes or otherwise? Do you know?
I don't think there's any that rely on it. I think they just allow you to, use those features, and then it's kind of up to you to make them work properly. They definitely don't provide any guarantees.
Yeah, like if there was a provider that used like container isolation with like Docker or whatever, open container, cryo or whatever, if they use that for isolation, then I would feel a lot more comfortable using it myself. But when when cloud provider don't do that for like their clients, I don't. It sounds a bit sketchy to me to like just try to harden it. I don't.
Yeah, I think you pretty much have to have control over a lot of how what the configuration is. Otherwise, it doesn't interact well with other things you're trying to do in your cluster. Yeah. And so they provide like it depends on your provider. Like Google has a variety of things that you can turn on that give you a good baseline of security, and then it's really up to you to then lock down the way containers run, make sure that you're using role-based access control and stuff like that, which isn't really so much an option anymore, but the way some people use it is just dumb. But yeah, I don't know that there's any easy answers.
The way the actions run, I don't think there's like they do Docker and Docker, I think I read. So you need to access
that's why it's kind of annoying to me that there isn't a way to like expose a Docker daemon, not necessarily like the same one, but like, and it's not necessarily Docker. Like in my Kubernetes cluster, there is no Docker. It's not Docker.
It's really fucking annoying, but the Docker developers seem to be really like opinionated on like there should only ever be one Docker daemon.
Yeah, I mean that's the problem. Like if you wanted to expose like a restricted Docker daemon that can, is heavily locked down, can only do certain things, there is no way to have both that and your main Docker daemon. They can't interact with each other, and that's really where the container runtime, I think, not necessarily Docker, but depending on what your container runtime is, there's really no reason why they couldn't have them aware of each other and able to like, not stomp on each other's feet, but still protect, certain sections of your infrastructure from potentially breaking out of a container. But I don't know, maybe there's things I'm not aware of
to merge that into Docker, but they just don't want to merge it. They just like don't ever merge stuff like that. The systemd folks have tried to make it possible to run systemd in containers, but they just like don't merge even like trivial small little things that would enable it. I don't really know what's going on there, but it's there's like a whole controversy, I think. But I guess like. Does the GitHub Actions runner have to use Docker, or can they use another container runtime?
My cluster, like I said, does not run Docker at all. It has like the Docker executable, the client, but the container runtime is not Docker on my cluster.
Okay. Well,
it's like whatever the new one is that Cryo. Kubernetes runs with. Is that the container runtime that Kubernetes is using now? I thought that's one piece of it.
There's the open container interface, and then before there was a Docker shim inside the process, but now it's like moved down.
Yeah, the shim is gone now.
Yeah, so now it's like a standard runner that runtime that interacts via the open container interface, and I think Cryo is one of the like more commonly used ones that are not Docker. Or I might be wrong about that.
Yeah, I can say that the actions runner controller that I set up, like that absolutely works without like real Docker. I don't necessarily know which container runtimes are compatible enough for it to work the way it's supposed to. And as long as, I think there's some restrictions on what you can do. There are things that you can do with real Docker that you can't do with the standardized runtimes, but nothing I've tried to do needs any of that. So I'm not sure that there are restrictions in any real sense, more for edge cases.
Yeah, that makes sense. Well, anyway, I think the best thing we can do is, as long as one of us signs the commits, I think that's fine in our case.
Yeah.
So if we can set that up, then we can make the runner. They're quite like powerful machines. I tried building Lumen on them when I tried doing it for that other guy, and I think it built LVM in like 3 minutes. So.
Shit.
Yeah, it's like 2 Xenons. They're like 2-3 year old like Google CDN servers.
Nice. Well, yeah, I mean, damn, even on a super beefy machine, I wouldn't have expected to be that efficient. I guess that just goes to show.
Yeah.
I mean, I guess the only caveat there is that in order for that to happen, you probably have to run it without resource limits or requests, so it can just do whatever it wants.
The cluster is like barely used, so I think like we should limit it a little bit, or at least like if we can like set some affinity or something, or like down prioritize it, then I think we should be fine. But yeah, whatever. If we can get like only running signed commits working, then we can start it up and have that running.
Yeah, I'm pretty sure. I was just gonna double check and see if I'm pretty sure there's a setting on a workflow that lets you specify who is able to trigger the workflow or the action. I can't remember if it's like which it is, but I'll try and go look at the docs, or if you get a chance, I think it's in the GitHub docs on workflows. I was looking at it not that long ago for a different thing, but I came across something to do with that along the way. If there's not direct support in workflows to do that, yeah, I'm open to trying to get some change that verifies the signed commits. The trick there, though, the actions runner doesn't have access to the source code. So we're sort of limited to what is in the payload from GitHub. So we verify the inbound like webhook payload, or however they interact with the runner. I can't remember exactly off the top of my head, but that payload contains all the information about like the push or the pull request, I think. I'm pretty sure one of those fields includes whether or not the commit was signed, and possibly the signature. We'd have to double check and see if the signature is in there. Then we can verify the signature.
The other way is you can build it on top of the secret end system, because GitHub won't disclose your environment to community pull requests. So if you have a secret environment variable, it won't get decrypted, and I think it might not even get set for a community pull request. And so you would just check for the environment variable, and if it's not set correctly, the runner shouldn't run it.
Yeah, that would be a good workaround.
Right.
It's got to be, yeah.
Yeah.
And if they've done that much, then I would think it's possible to access who's actually triggering the workflow from the workflow itself. That'd for sure be the easiest way to deal with this. But the thing we have to be careful about is, since you can forge a commit, is to make sure that we're not checking a field that can be forged. That's the only tricky part. But I'm pretty sure the actual authenticated user that triggers workflow can be accessed in the workflow.
Well, awesome. I think that's everything for me, at least.
Awesome. Well, guess we'll check in again next week, and yeah, let me know, Luke, if you run into any issues there.
Okay.
Getting that assembly work or reworked. Talk to you guys there.
Aye.